All right, so in 11.1, we kind of started talking about this the other day, the square root property. The square root property, which says, okay, if I have a number squared equal to a number, to get the x by itself, I would do the square root of both sides. Square and the square root would cancel out, and I get x equals the square root of 144 is 12. The problem with that is that I could do 12 squared to get 144, but I could also do negative 12 to get 144. So since positive 12 equals 1, or 12 squared equals 144, and negative 12 squared equals 144, the way I do that is anytime I take the square root inside an equation, I put plus or minus, which is essentially two different answers, negative 12 and positive 12. If I had x squared equals 81, I take the square root, the square and the square root cancel out. As soon as I take the square root inside the equation, I write plus or minus. The square root of 81 is 9. Anytime you have just an x squared in a problem, you can do this. Most of the problems we've done look like x squared plus some number plus c. Anytime this term's not there and you have just the x squared, you can solve like this. So even if you had x squared minus 4 equals 0, the first thought that may come to your mind would be to factor that and say x times x is x squared, 2 times 2 is 4. So you do what? Plus 2 minus 2. And then solve both of those. So x plus 2 equals 0, x minus 2 equals 0. So you subtract 2 and you add 2. So you get negative 2 and positive 2. But since this one only has an x squared in it, what you can do is just do x squared minus 4 equals 0. Add 4 to both sides. And then take the square root of both sides. So you get x equals plus or minus 2. Which that's a lot shorter than that to me. Anytime you have just an x squared, you can solve for the x squared and take the square root of both sides. Okay, so if you have more than one thing in there, again, there's only an x squared here, so let's just solve for x squared, get x squared by itself. So add 5 to both sides. And then divide both sides by 2. Did you got that? I don't think it was over there when I went over there. Well, there's somebody in this room. Yeah. Somebody, I'm sure it's somebody in this classroom. So then you take the square root. Once you get the x squared by itself, and you get x equals plus or minus 5. It wasn't over there when I went to the trash can a second ago, so it's either you or Taj. You're the only two that walk in. It's not your $5, is it? All right, you can also have, I guess we've done one of these, x squared equals, you have x squared equals positive 49. So here we subtract 49 from both sides, and you get x squared equals negative 49. So when I go to take the square root, it's not, there's something else. Square and square root cancel out, you get plus or minus 7 what? I, because it's negative 49. If there's a negative on the square root, you can't forget the I. We're going to go back over all that square root stuff today. Guess we might as well do it. So if you have a negative under the square root, you put an I. That was your $5? All right, fight about it. So if you have a negative under the square root, you put an I. What other one? Oh, if I have this right here. So again, it's still the same idea. I'm going to take the square root of both sides. but the square root of 72 doesn't break down. So that means you've got to do jailbreak or one of those. So the 2's come out, and the 3's come out, and this 2 doesn't have any friends. So you get 6 on the outside, and the square root of 2. So you got to put plus or minus because we did the square root. So we're going to break down radicals again today. If you have the negative on the square root, you got to put I. Oh, I know what I need to do. Yeah, we'll just start with something like this. All right, so here you've got this squared equals 17. So just over here you had something squared equals 17. Well, this is just something squared equals 17. So that's all being squared. So again, I can just take the square root right here. The square and the square root will cancel out, and I'll have x minus 3 equals plus or minus, since I took the square root, 17. Well, now to get x completely by itself, I need to move this 3. So add 3 to both sides. We can just write 3 plus or minus the square root of 17. In my math lab, they do not have a plus or minus button, so that is 3 answers. It is, or 2 answers, I mean. 3.
Right off the bat, when you square both sides, would you put a plus or minus?
Why did I put that? Anytime you take the square root inside an equation, you have to put plus or minus. So anytime you do that square root, you have to do that. Right. So my math lab doesn't have a plus or minus button, so you do have to write 3 plus the square root of 17 and 3 minus the square root of 17. It's 2 different answers. So it's just separating out plus and minus out. If you had one like this, again, you have something squared equals 64. So to get rid of that squared, I'm going to do the square root of both sides. Get x minus 5 equals, what's that become? So you got to put the plus and minus 8. And then to get the x by itself, you add 5 to both sides. Get x equals 5 plus or minus 8. Again, that's 2 different answers. So 5 plus 8 and 5 minus 8. So 5 plus 8 is 13. 5 minus 8 is negative 3. So that's my 2 answers, negative 3 and 13.
So after you find the square root of 64, you can't add 5 to both sides?
That's what we did. We added 5 right there.
Wait, I mean, add 5 to the 8. You can do that because the plus and minus?
You can't just add the 5 to the 8 because of plus and minus. So you have to do 5 plus 8 is 13, and 5 minus 8 is negative 3.
So it's going to be those 2 answers.
So those are your 2 answers, yeah. So add 5 and then worry about that plus and minus. Three squared. I'll see that before it's not 3. All right, so one like this, yeah, again, you have something squared equals negative 49. So you take the square root of both sides. What do I get on the right side? That's half of it.
Plus or minus.
Plus or minus. So now I've got all this on this side. Well, just solve for x like you normally would. Add 3 to both sides. 3 plus or minus 7i, and then divide by 4. So x is equal to 3 plus or minus 7i divided by 4. You know what? I wonder, all those complex numbers have to be in that a plus bi form. So I'm guessing my math lab is going to make you separate that out. What'd you say?
I'm so glad we have doing tests in this class.
Written test?
I'm so glad we have written tests in this class.
Written test.
Yeah, my math
Written.
lab is
Gotcha.
difficult to do.
Written. Yeah, the computer wants to be a pain because no partial credit or anything. All right, so now that's a square root property, which we kind of touched on that or introduced it the other day. What is left is what happens when you can't factor a problem. Every other problem so far we just wrote can't factor and that's it. But you still can solve them and get an answer. So there's two different ways to do that. 11.1, the last 7 questions here are completing the square, and then the next section is quadratic formula. I would suggest picking one way and doing it. And I know which way y'all are going to pick, so I'll probably just do a lot more of those than I will this way. But let's talk about completing the square real quick. Most people do not like this. I gotta at least show it in case you plan on taking more math classes. Completing the square. All right, so the way completing the square works is if I had, let me go get the numbers here. If I had this problem right here, the first thing you always want to try to do is factor it. So you go through the factoring steps. Is there anything that multiplies to be 15 and adds up to be 16?
15-1.
Did I not write that down right? For that one. Oh. Well, dang it, I want to do one that can't factor.
Or dead.
No, there's somebody showed me a different factoring way. I was going to show you. It wasn't a different factoring way. It was a way to come up with these numbers, which is kind of strange. I was going to show you, but I'm not going to show you. Not right before test. All right, so let's try that again. X squared plus 18x equals 17. Plus 7. All right, so I believe if you went through all the numbers here, this would not cancel. This wouldn't work out. There's nothing that multiplies to be 78 and adds up to be 18. Okay, so completing the square, what we're going to do, oh, I forgot an x there, didn't I? What we're going to do is manipulate this to factor for us. So the first thing we want to do is get the x squared and the x by itself. So I'm going to move this 78 to the other side. So I have a blank here. All right, so I have x squared plus 18x. Ignore the right side for a minute. On the left side, I'm going to manipulate this to come up with a number here that will make this easily factorable. Okay, complete the square. I'm going to do actually a perfect square number here. So the way you find that number, the way you find this number is you would do b over 2 squared. What b means is that number in the middle, right? I wrote this equation out before. B is a number by the x. So you do 18 over 2 squared, which is 9 squared, which is 81. So what that means is if I put an 81 right here, the left side should be easily factorable. It should be a perfect square factor. So if I look at it, it should break down to two factors like this. X times x is x squared. What multiplies to be 81 and adds up to be 18? 9. Really, it's always going to just be half of this. So 9 and 9, and it's both going to be plus, right? Because plus 9 times 9 is 81, 9 plus 9 is 18. So I'm going to write this like this, x plus 9 squared. All right, so I added 81 on the left side to make this side factorable. But now the right side, I got to go look at. Well, if I added 81 here, I got to add 81 on the right side. So on the right side, I have negative 78 plus 81, which is 3. Well, now this is just like a problem we were doing a second ago. You have something squared equals a number, so you take the square root of both sides. So you get x plus 9 equals plus or minus the square root of 3. And then subtract 9 from both sides, so you get x equals negative 9 plus or minus the square root of 3. And you can tell this one would not be factorable because there's no way I could get a square root if I was factoring. So again, we kind of manipulated this problem to make it factorable on the left side. And then we had to work out the right side by just adding. So if you want to go back and do that one that we had on the screen, just to show you. So here, all right, so we need to figure out what number makes this side factorable. So you do b over 2 squared. Cut the middle number in half and then square it, so a squared is 64. So if I add 64 on the left side, I have to add 64 on the right side. So now this one right here will always break down into this form. What number goes right here? What? Yes, well, multiplies to be 64, adds up to be 16. It's not a coincidence, too, that it's always this number cut in half. 16 divided by 2 is 8. So negative 15 plus 64 is 49. To find this 64, we're trying to find a number to make this a perfect square to factor easily like this. So you always cut this number in half and then square it. So you get 16 divided by 2, which is 8. 8 squared is 64. So now just go do the square root of both sides. So you get x plus 8 equals plus or minus 7. Well, now we can just subtract 8 and get x equals negative 8 plus or minus 7. So x equals negative 8 plus 7 and negative 8 minus 7, which is negative 1 and negative 15. All right, so the first step on this one, again, is to, well, I guess we did that on the first one, but move this number to the other side. Move this number to the other side, so we just have the x squared and the x, and then we can come up with a number here. The first step, or to actually completing the square, is you cut this number in half, okay? So completing the square works really well when this is an even number. But if this was an odd number and I had to cut it in half, say it was 7, you get 7 over 2, and then you got to do the whole problem in fractions. So these are the easy complete the square problems. When you start doing a fraction, it makes it a lot tougher because I know y'all don't like fractions. Or if there's a number in front of x squared, you can't have a number in front of x squared when you complete the square, so it makes it even harder. So I don't do a lot of complete. What? You have to divide everything by that number. I can do one just to show you. It's not very fun, but I can show you. 3x squared plus 23x equals 8. I don't show you a lot of complete the square because most of you will just use quadratic formula. Here, this problem will just satisfy your hate to complete the square. But I do just want to just introduce it, and then if another class you take college algebra, I know you only didn't pre-calculus if you haven't happened to take that. College algebra, if somebody does it, then you've seen it before. All right, well, you can't, well, no, you want to keep that 8 on the other side when you complete the square because you want the x squared and the x by itself. But you cannot have this 3 in front. So I'm going to divide everything by 3. So this cancels out, and I get x squared plus 23 over 3. Hold on, that shouldn't cancel the whole thing out. Remember, 23 over 3x plus or equals 8 over 3. I shouldn't have said cancels out there. 3 divided by 3 is 1. 23 divided by 3 is just 23 thirds. This is a problem I would recommend doing quadratic formula on anyways. All right, so now to find this number that goes here, you do 23 over 3 and you cut that in half. Well, what actually happens is this 3 comes down, so it's actually 23 over 6 squared. What is 23 squared? 576. 4. 529. Okay. So that's 529 over 36. So I add 529 over 36 to this side, and I add 529 over 6 to this side. 36, I mean, not 6. All right, so this one always breaks down. This one always breaks down to whatever's inside the parentheses here. So it would be x plus 23 over 6. It's 23 times 23 is 529. 6 times 6 is 36. 23 plus 23 over 6 plus 23 over 6 is actually 23 over 6. And then this one, to add these up, we got to get common denominator. All right, so I need that to be 36. So I multiply both sides by 12. 12 times 8 is 96 plus 529. 624. 625. So now I do the square root of both sides, and I get x plus 23 over 6 equals plus or minus 625 is 25 over 6, though. Right? So now subtract the 23 over 6 from both sides. You get plus or minus 25 over 6. We can actually work that out. So negative 23 plus 25 over 6. Negative 23 minus 25 over 6. 2 over 6 or 1/3. Negative 48 over 6 or negative 6. So there's my two answers. Which means, since we got normal numbers there, that we could have just factored it from the beginning. But that is why completing the square is a pain. If you have a number in front, you got to divide it out. If you have a fraction there to work with, I know y'all hate fractions, so it makes it tougher. So honestly, I'd recommend doing those last 7 problems in 11.1 and then all the ones in 11.2 as the quadratic formula, which we're fixing to go over. X squared minus 6x plus 4. All right, so 11.2. The quadratic formula. So the equation that we just wrote a minute ago was ax squared plus bx plus c equals 0. The quadratic formula is solving for x on unfactorable problems. You can do this for every single problem on the test if you wanted to. Even the factoring ones, this will work. Not every single, because there's stuff in the review, but every factoring problem you can do. So it is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Which I'll probably give it to you, write it on the board if you, just remind me on.
What is that in the graph for?
B squared minus 4ac. Most people have memorized. I think my algebra teacher in high school taught me to pop goes the weasel, all over 2a. And that's the pop goes the weasel part. But I don't really see any need for you to memorize that. So I'll probably write it on the board. But, so this solves everything. All you got to do is figure out what a, b, c are and plug them in. And then it becomes a big simplifying problem. If I have x squared plus 6x minus 4 equals 0. Now, again, it's always easier to factor. Always easier to factor, but so you always check it. What multiplies to be 4 and adds up to be 6. There isn't anything. So here, my a is 1. A is a number in front of x squared. B is a number in front of x, which is 6. And c is the constant by itself, which is negative 4. So that's the first thing you got to figure out what A, B, and C are. So the first thing you want to do is put it all equal to 0, so everything's on one side. Write down what A, B, and C are. So now plugging it into this formula right here up top, the opposite of B means that if this is positive B, I'm going to make it negative. So the opposite of B, plus or minus B squared minus 4 times A times C, all over 2 times A. Now, like I said, you've got all these numbers in, so this is just a big order of operations simplifying problem right now. So what I do is try to focus on one part at a time. So I pull the square root over and work it out. So 6 squared is 36. Negative 4 times 1 times negative 4 is positive 16. So when you add those up, you get the square root of 52. Can I break down the square root of 52? 2 and 26, 2 and 13, right? So this becomes 2 square roots of 13. So that kind of helps me make it a smaller problem by just looking at that first. So now I come back over here and I write negative 6 plus or minus what we got divided by 2. There's one last thing I can do here. How many terms do I have in this problem? 3. How many can I divide by 2?
1.
Divide all 3 of them, right? This one has a 2 on the outside, this has a 2, and this one has a 2. So I end up with negative 3 plus or minus the square root of 13. Divide that by 2, divide that by 2, divide that by 2. So there's my 2 answers. Negative 3 plus the square root of 13, negative 3 minus the square root of 13. This one is more methodical, step-by-step, kind of less thinking than complete the square. It's just, like I said, you plug it all in and then it's a big simplifying problem. Y squared plus 6y plus 34. So I guess, I'm sorry if you already wrote this down, but if you have something like this, the first thing you always want to do here is to get everything on the same side. So I add 34 to the other side. So here again, my A is 1, my B is 6, my C is 34. So I do the opposite of B, plus or minus B squared minus 4 times A times C, all over 2 times A. I pull the radical to the side to work it out. So 6 squared is 36. 4 times 1 times 34 would be negative 136. Somebody better double check that. I bet it is negative 136.
So you multiply the 4 to a 1 or negative 4.
Yeah, I do that as
Answer the 34. Negative 4.
well, just multiply them all at once. Just in the calculator, negative 4 times 1 times 34. Not like distribute. Is that right? So the square root of negative 100 becomes what?
What's that?
What do you mean was what? How did I get that?
36.
Somebody said it. 10i. So I have negative 6 plus or minus 10i divided by 2. Again, can I divide all those by 2? So I get negative 3 plus or minus 5i. I guess that's what x equals. X equals this.
I like the way you do it when you take the radical and you do it first before you do everything else.
Yes.
I wouldn't do it that way.
Right. No, that's what, if you don't take the radical and try to do try to do just this part first and ignore this, and we'll let the side do it, you get mixed up with all the other stuff. It's a big problem, so just kind of pull it to pieces and work the pieces that you can. Let's go to. We have done one more. Here, we have done one like this. 7m squared minus 2m. All right, so again, on this one, the first thing you want to do is get that 6 to the other side. So you have 7m squared minus 2m minus 6 equals 0. So here my A is 7, my B is -2, and my C is -6. So you have the opposite of B. This time B is -2, so you do +2. Plus or minus B squared minus 4 times A times C all over 2 times A. So take the radical, so -2 squared is 4, -4 times 7 times -6. What'd you say? Oh, -28 times 6.
Oh.
-168?
160.
160?
116.
Okay. 168. So now that's the square root of 172, so let's break it down. 2 will go into it, right? You don't have to try to get a big number to start. 2 and 86. 2 and 43. So 2 square roots of 43. So now that I've simplified that, do 2 plus or minus 2 square roots of 43 over 14. So now I can divide all those by 2, right? So it become 1 plus or minus the square root of 43 over 7. What? Yes, in my math lab, you're going to have to put 1 plus or minus square root of 43 over 7, 1 minus the square root of 43 over 7, because it does not have a plus or minus square. No idea why it doesn't have a plus or minus square. One thing I do need to say on those, because we haven't run across them yet, if you end up with this right here, can I divide all those by 2?
No.
Why? Because that's under the, no, that's right. So there's actually a 1 right here, and I cannot divide 2, 1, and 4. I cannot mess with under the radical because this is outside the radical. So that would be as simplified as that gets. Let's do this fraction one. Oh, there's part fraction one. Gonna do that one. The fraction ones aren't as bad as you think they're going to be. 1/2 x squared plus 4x plus 5. Because what do you do when you don't want to deal with a fraction? Multiply by the denominator or the LCD to make them all cancel out. So my LCD here is 2 because there's only one of them. Just multiply everything in here by 2. So these cancel out and I get x squared. That becomes 8x. That becomes 10 and that becomes 0. So now just like normal and I don't have to deal with a fraction. So here the opposite of, oh wait, let's label these. A is 1, B is 8, C is 10. So the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So underneath the radical is what, 64 minus 40? Which is 24. So it becomes 2 square roots of 6 because those go back in. So you have negative 8 plus or minus 2 square roots of 6 over 2. And I can divide all three of those, so you get negative 4 plus or minus the square root of 6.
I have a question.
Yes.
You're not dividing by the denominator, you're dividing by 2. So if that was 6 in the bottom, you'd still be dividing by 2.
Right.
Okay.
So like, yeah, if you had, you're saying if I had like 8 plus or minus 4 over 3 divided by 6 like this,
Right.
then you divide all these by 2, so it'd become 4, 2, 3, so it'd be 4 plus or minus 2 square roots of 3 over 3.
And why are you dividing by 2?
Because it's like simplifying. I can
Okay.
divide all three of those by 2, so I'm just simplifying it down.
Okay.
All right, so I would assume, especially the way y'all are acting, I just know from the past, everybody chooses quadratic formula, which is fine. You can literally do this for every problem, even just to show you.
It's always difficult to with the quadratic formula to show you how to do it.
With the radical, just focus on one thing at a time instead of trying to look at the whole picture. That's the reason the state makes you take math classes, is because of that thinking of trying to be able to separate stuff out and then put it back together. It's the logical problem solving. Which problem do I want to show you? Those problems we were doing earlier today. That's fun. It's like if I had 2x squared plus 50 equals 0, like this problem. I can still use quadratic formula for this because it'd be like, well, wait, hold on. Every problem we did was like this, right? So wouldn't this be like 2x squared plus 0x because there's nothing there? There is no x, so just write 0x. So here my a is 2, my b is 0, my c is 50. So you do the opposite of b, well, the opposite of 0 is 0. Plus or minus b squared minus 4 times a times c all over 2 times a. So 0 squared is 0. Negative 4 times 2 times 50 is negative 400. So what's the square root of negative 400? 20i. Well, 0 plus or minus 20i over 4. Well, 0 plus or minus anything is 0, right? The 0 doesn't really do anything there. Because 0 plus 20i is still 20i, 0 minus 20i is still 20i. So you have plus or minus. Can I divide those by something though? The answer is actually plus or minus 5i.
So this one you did divide by the denominator.
Right, but it's still the idea of simplifying. Divided by 4, divided by 4. If I divide that by 4, I get 5. Divide that by 4, I get 1. So 5 over 1 is the same thing as 5.
You simplify to
Right, just like fraction. Now I guess I shouldn't say that works on every problem on the test. That works when you have an equal sign, okay? Because you're solving for x, you're trying to get x equal a number. So that will work. Anytime you have an equal sign and trying to solve a quadratic equation, that will work. You can put a 0 in if a number is missing. That is it for this chapter. So we plan on